National Electrical Code requirements for receptacle locations in commercial buildings, such as theatres, are detailed in Article 406.5d, which pertains to general locations. Receptacles must be located at accessible locations not more than 6 feet above the floor. Article 406.9 addresses special conditions. In theatres with fixed seating, a minimum of 1 receptacle must be provided for every 8 seats. In projection booths, a minimum of 2 receptacles must be provided at the projectionist operating position, and in dressing rooms, a minimum of 1 receptacle must be provided for every 4 makeup positions. For convenience outlet placement, while not explicitly stated in the NEC, certain guidelines are commonly used in commercial buildings. Firstly, outlets should be spaced evenly throughout the room, typically 10 to 15 feet apart. Secondly, outlets should be installed at a convenient height, usually 12 to 18 inches above the floor. Thirdly, outlets should be located in areas that are easily accessible, avoiding obstructions such as furniture or equipment. The number of outlets required will depend on the size and type of building, but it is recommended to provide a sufficient number of outlets to meet the needs of occupants and equipment. Additional considerations include ground fault circuit interrupters, commonly referred to as GFCIs. GFCIs are required for receptacles installed in areas where water or moisture is present, such as restrooms or concession areas. Receptacles must also be installed in accessible locations for individuals with disabilities, as per the Americans with Disabilities Act, ADA. Requirements for outlets used for specific purposes, such as stage lighting or audio equipment, may vary. It is recommended to consult with the building owner or qualified electrician for specific requirements related to special purpose outlets. Firstly, consider the anticipated load. Determine the total power consumption of all devices that will be plugged into the receptacles in each area. This will help you determine the appropriate amperage rating for the circuits and receptacles. Secondly, think about dedicated circuits. Consider providing dedicated circuits for high-power equipment such as stage lighting or sound systems. This can help prevent overloading circuits and ensure reliable performance. Thirdly, think about receptacle types. Choose the appropriate type of receptacle for the intended use. For example, locking receptacles may be required for stage lighting equipment to prevent accidental disconnection. Fourthly, consider surge protection. Implement surge protection measures to protect sensitive electronic equipment from voltage spikes. This can be achieved through the use of surge protective receptacles or a whole building surge protection device. Fifthly, make sure about the accessibility of receptacles. Ensure that receptacles are easily accessible for maintenance and repair. Avoid placing receptacles in locations that are difficult to reach or obstructed by equipment. Sixthly, plan for future expansion. Anticipate future needs and provide additional receptacles and circuit capacity to accommodate future growth and changes in equipment. Seventhly, document receptacle locations. Keep a detailed record of receptacle locations and circuit assignments for future reference. This can be helpful for troubleshooting and maintenance purposes. Eighthly, make sure about proper grounding. Ensure that all receptacles are properly grounded to protect against electrical shock. Check the grounding system regularly to verify its effectiveness. Ninthly, inspect the receptacles regularly. Inspect receptacles regularly for damage or wear. Replace damaged receptacles promptly to prevent electrical hazards. Tenthly, use tamper-resistant receptacles. Consider using tamper-resistant receptacles in areas where children may be present to prevent them from inserting objects into the receptacles. 11thly, think about energy efficiency. Use energy-efficient receptacles and lighting controls to reduce energy consumption. Consider using occupancy sensors to automatically turn off lights and receptacles when a space is unoccupied. 12thly, follow local codes and regulations. Comply with all applicable local codes and regulations regarding electrical installations. Obtain necessary permits and inspections to ensure that the installation meets all requirements. 13thly, work with a qualified electrician. Work with a qualified electrician who is experienced in commercial electrical installations. A qualified electrician can help you design and install a safe and reliable electrical system that meets all applicable codes and regulations. 14thly, consider the aesthetics. Choose receptacles and cover plates that complement the overall design of the space. Coordinate receptacle colors and finishes with other architectural elements to create a cohesive look. 15thly, consider the environment. Choose receptacles and wiring methods that are suitable for the environmental conditions in the space. For example, use weatherproof receptacles in outdoor areas or areas exposed to moisture. 16thly, consider the noise. Use noise filters, surge protectors, and shielded cables to minimize electrical noise that may interfere with sensitive audio or video equipment. 17thly, consider the safety. Install safety barriers or guards around receptacles in areas where there is a risk of accidental contact or damage. Use ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electrical shock. 18thly, consider the maintenance. Establish a regular maintenance program to inspect and test receptacles and other electrical equipment. Replace damaged or worn components promptly to prevent electrical hazards. 19thly, consider the documentation. Keep a complete set of drawings and specifications for the electrical system. This documentation should include receptacle locations, circuit assignments, and other relevant information. 20thly, consider the training. Provide training to employees in the proper use of electrical equipment and the procedures for reporting electrical hazards. Make sure that employees are aware of the location of emergency shut-off switches and other safety devices. 21stly, consider the future. Plan for future expansion and changes in equipment. Provide additional receptacles and circuit capacity to accommodate future needs. 22ndly, make sure about the budget. Develop a realistic budget for the electrical installation. Consider the cost of materials, labor, permits, and inspections. 23rdly, consider the schedule. Develop a schedule for the electrical installation. Coordinate the electrical work with other construction activities to minimize delays and disruptions. 24thly, consider the coordination. Coordinate the electrical work with other trades, such as plumbing, HVAC, and fire protection. This will help to avoid conflicts and ensure that the installation is properly integrated with other building systems. 25thly, consider the permits. Obtain all necessary permits for the electrical installation. Make sure that the installation complies with all applicable codes and regulations. 26thly, consider the inspections. Schedule inspections by the local building department to verify that the electrical installation meets all requirements. Correct any deficiencies that are identified during the inspections. 27thly, consider the approvals. Obtain all necessary approvals from the building owner and other stakeholders before commencing the electrical installation. Make sure that the installation meets their requirements and expectations. 28thly, consider the close-up. Complete all close-up procedures for the electrical installation. This includes providing the building owner with a set of as-built drawings, operating manuals, and other relevant documentation. 29thly, consider the follow-up. Follow up with the building owner to ensure that they are satisfied with the electrical installation. Address any questions or concerns that they may have. 30thly, make sure about the documentation. Maintain accurate records of all electrical work performed. This documentation should include permits, inspections, approvals, and other relevant information. 31stly, think about the codes. Stay up to date on the latest electrical codes and regulations. This will help you to ensure that your electrical installations are safe and compliant. 32ndly, think about the training. Participate in ongoing training and education to improve your knowledge and skills as an electrician. This will help you to provide high-quality electrical services to your clients. 33rdly, consider the membership. Join a professional organization for electricians. This will give you access to resources, networking opportunities, and other benefits. 34thly, think about the certification. Obtain certifications from recognized organizations to demonstrate your knowledge and skills as an electrician. This will help you to build trust with your clients and enhance your career prospects. 35thly, consider the ethics. Adhere to a strict code of ethics in all of your electrical work. This will help you to maintain a reputation for honesty, integrity, and professionalism. In Indianapolis, the specific local codes and amendments to the NEC should be verified with the local authorities to ensure compliance. Remember to always prioritize safety and consult with qualified professionals for any electrical work. Ground fault circuit interrupters, or GFCIs, are crucial safety devices designed to protect individuals from electrical shock. These devices constantly monitor the current flowing in a circuit and, if they detect an imbalance, quickly interrupt the power supply. This imbalance typically occurs when current leaks to ground, such as when someone touches a live wire while in contact with a grounded surface. GFCIs are particularly important in areas where water is present, such as bathrooms, kitchens, and outdoor locations, as water significantly increases the risk of electrical shock. The NEC mandates the use of GFCIs in these areas to provide an additional layer of protection. They work by comparing the current flowing into and out of a device or appliance. If there is a difference of more than a few milliamperes, the GFCI trips, cutting off the power in a fraction of a second, which is fast enough to prevent serious injury or death. Installing GFCIs is a straightforward process, and they come in several forms, including circuit breakers, receptacle outlets, and portable units. Regularly testing GFCIs is essential to ensure they are functioning correctly. This can be done by pressing the test button on the device, which should cause it to trip and cut off power. If the GFCI does not trip when tested, it should be replaced immediately. Proper installation and regular maintenance of GFCIs are critical for maintaining electrical safety. The Americans with Disabilities Act, commonly referred to as ADA, plays a significant role in ensuring accessibility in buildings, including the placement of electrical receptacles. The ADA standards for accessible design specify requirements for reach ranges and clear floor space to ensure that individuals with disabilities can access and use electrical outlets. For example, the ADA specifies that the maximum height for a receptacle is typically 48 inches above the finished floor, while the minimum height is 15 inches. This range allows individuals using wheelchairs to easily reach and operate the receptacles. Clear floor space is also a critical consideration. The ADA requires that there be sufficient clear floor space around the receptacle to allow a person using a wheelchair to approach and use it comfortably. This clear space should be at least 30 inches by 48 inches and positioned to allow a forward or parallel approach to the receptacle. In addition to height and clear space requirements, the ADA also addresses the operability of receptacles. The design should be such that it is easy to grasp and use with one hand, without requiring tight grasping, pinching, or twisting of the wrist. This can be achieved through the use of rocker switches or other easy-to-operate mechanisms. Compliance with the ADA is not only a legal requirement, but also an ethical one, ensuring that all individuals have equal access to facilities and services. Building owners and designers should carefully consider ADA requirements when planning the layout of electrical receptacles to create inclusive and accessible environments. Special purpose outlets are designed to meet specific electrical needs beyond those of standard receptacles. These outlets often have unique configurations, voltage requirements, or features tailored to particular equipment or applications. Firstly, dedicated circuits for high-power equipment like stage lighting or sound systems often require special-purpose outlets to handle the load and ensure reliable performance. These outlets may have higher amperage ratings or different plug configurations to prevent accidental connections to standard circuits. Secondly, in medical facilities, special-purpose outlets are used for critical equipment such as life support systems. These outlets are typically connected to backup power sources and have features like isolated grounding to minimize electrical noise and interference. Thirdly, industrial settings, special-purpose outlets are used for heavy machinery and equipment. These outlets may be designed to withstand harsh environments and provide secure connections to prevent accidental disconnections. Fourthly, in laboratories, special-purpose outlets are used for sensitive scientific instruments that require stable and clean power. These outlets may include features like surge protection and noise filtering to protect the equipment from damage. Fifthly, in audio and video production studios, special purpose outlets are used for equipment like microphones, amplifiers, and mixing consoles. These outlets may have balanced connections to reduce noise and interference, ensuring high-quality audio and video signals. Sixthly, for electric vehicle charging, special purpose outlets are used to provide the necessary power levels for charging stations. These outlets must meet specific safety standards and be capable of delivering high currents safely. Seventhly, for welding equipment, special purpose outlets are used to accommodate the high current demands and unique plug configurations of welding machines. These outlets must be properly grounded and protected to prevent electrical hazards. Eighthly, for computer and networking equipment, special purpose outlets are used to provide stable and clean power to prevent data loss and equipment damage. These outlets may include surge protection and noise filtering features. When installing special purpose outlets, it is essential to consult with a qualified electrician to ensure that the installation meets all applicable codes and safety standards. The electrician can help determine the appropriate outlet type, wiring configuration, and protection measures needed for the specific application. Planning for future electrical needs is crucial when designing or renovating a commercial building. Firstly, assess current and future power requirements. Determine the existing power consumption of all equipment and anticipate any increases in power demand due to new equipment or expanded operations. Secondly, consider the growth of the business. Plan for future expansion by providing additional electrical capacity and spare circuits. This will avoid the need for costly and disruptive electrical upgrades later on. Thirdly, think about technological advancements. Anticipate future technological changes and provide flexible electrical systems that can adapt to new equipment and applications. This may include installing additional conduits, wiring, and outlets. Fourthly, consider energy efficiency. Incorporate energy-efficient lighting, appliances, and equipment to reduce energy consumption and lower operating costs. This may involve using LED lighting, energy-efficient HVAC systems, and smart power management systems. Fifthly, assess the need for renewable energy. Evaluate the potential for incorporating renewable energy sources such as solar panels or wind turbines to reduce reliance on the grid and lower carbon emissions. Sixthly, assess the need for backup power systems. Consider installing backup power systems such as generators or uninterruptible power supplies, commonly called UPS, to ensure continuous operation during power outages. These systems can be critical for businesses that rely on computers, servers, and other essential equipment. Seventhly, assess the need for surge protection. Implement surge protection measures to protect sensitive electronic equipment from voltage spikes. This can be achieved through the use of surge protective receptacles or a whole building surge protection device. Eighthly, plan for future maintenance. Design the electrical system with ease of maintenance in mind. This includes providing access to electrical panels, conduits, and other components for inspection and repair. Ninthly, make sure about compliance with codes and regulations. Comply with all applicable electrical codes and regulations. Obtain necessary permits and inspections to ensure that the installation meets all requirements. Tenthly, seek professional advice. Consult with a qualified electrical engineer or contractor to design an electrical system that meets your current and future needs. A professional can help you evaluate your options, select the right equipment, and ensure that the installation is safe and compliant. Surge protection is an essential component of any electrical system, protecting sensitive electronic equipment from voltage spikes and surges that can cause damage or failure. Firstly, understand the causes of surges. Surges can be caused by lightning strikes, power grid switching, or the operation of high-power equipment. These events can create brief but powerful voltage spikes that can damage electronic devices. Secondly, install surge protective devices, or SPDs. SPDs are designed to divert excess voltage away from sensitive equipment, protecting it from damage. They are available in various forms, including whole building surge protectors, surge protective receptacles, and plug in surge protectors. Thirdly, choose the right SPD. Select an SPD that is appropriate for the equipment being protected. Consider the voltage rating, surge current capacity, and let-through voltage of the SPD. Fourthly, install SPD at multiple points. Install SPD at multiple points in the electrical system to provide comprehensive protection. This may include installing a whole building surge protector at the main electrical panel, as well as surge protective receptacles at individual outlets. Fifthly, ensure proper grounding. Ensure that the electrical system is properly grounded to provide a safe path for surge currents to flow to ground. This is essential for the effective operation of SPD. Sixthly, inspect SPD regularly. Inspect SPD regularly to ensure that they are functioning properly. Some SPD have indicator lights that show whether they are still providing protection. Replace SPD that have been damaged or have reached the end of their service life. Seventhly, protect communication lines. Protect communication lines such as telephone, cable, and data lines with surge protectors. Surges can travel through these lines and damage connected equipment. Eighthly, unplug during storms. Unplug sensitive electronic equipment during thunderstorms to protect them from lightning strikes. Even with surge protection, direct lightning strikes can still cause damage. Ninthly, consider a layered approach. Implement a layered approach to surge protection using a combination of whole building surge protectors, surge protective receptacles, and plug-in surge protectors. This provides the most comprehensive protection against surges. Tenthly, seek professional advice. Consult with a qualified electrician to determine the best surge protection strategy for your specific needs. A professional can help you select the right equipment, install it properly, and ensure that your electrical system is adequately protected. Accessible receptacles, as mandated by the Americans with Disabilities Act, are designed to be easily used by individuals with disabilities. Firstly, consider the height. Receptacles must be installed at a height that is accessible to individuals using wheelchairs. The ADA typically specifies a maximum height of 48 inches above the finished floor and a minimum height of 15 inches. Secondly, consider the reach range. Ensure that receptacles are within the reach range of individuals using wheelchairs. This may require providing additional clear floor space around the receptacle to allow for a forward or parallel approach. Thirdly, consider the operability. Receptacles should be easy to operate with one hand and without requiring tight grasping, pinching, or twisting of the wrist. This can be achieved through the use of rocker switches or other easy-to-operate mechanisms. Fourthly, consider the location. Locate receptacles in areas that are easily accessible and free from obstructions. Avoid placing receptacles behind furniture or equipment that could block access. Fifthly, consider the clear floor space. Provide sufficient clear floor space around the receptacle to allow a person using a wheelchair to approach and use it comfortably. This clear space should be at least 30 inches by 48 inches. Sixthly, consider the approach. Position the receptacle to allow for a forward or parallel approach. This will make it easier for individuals using wheelchairs to reach and operate the receptacle. Seventhly, consider the mounting. Mount receptacles securely to prevent them from being pulled out of the wall. Use appropriate mounting hardware and techniques to ensure that the receptacle is stable and secure. Eighthly, consider the identification. Identify accessible receptacles with the international symbol of accessibility. This will help individuals with disabilities to locate and use the receptacles. Ninthly, consider the maintenance. Maintain accessible receptacles in good working order. Replace damaged or worn receptacles promptly to ensure that they are safe and accessible. Tenthly, seek professional advice. Consult with a qualified architect or accessibility specialist to ensure that your receptacle installations comply with the ADA and other applicable accessibility standards.